Okay, now let us see how we handle more examples about crossing a river. So start with this one. It says, a boy wishes to swim across a river 100 meters wide. The river flows, so they are giving us the velocity of the flow of water. So they are giving us the velocity of the water in the river is 3 kilometers per hour. And then the boy can swim at, so the velocity of the boy is 4 kilometers per hour. Okay, in still water, find the time it takes the boy to swim across the river and how far, to cross the river and how far down the stream he travels. So there we first draw our river. This is going to be our river. It's going to look like that. Okay, so from there, you can see that telling us that this one is 100 meters wide. Okay, so they want us if this is our point A and this is our point, okay, if I'm say this is going to be point A and this is point B, of course it's going to go down the stream. This is going to be at point C. So mean that now our resultant velocity is going to be this VR. So they are telling us that of course this man, the man, this boy or a boy, this is his velocity VB, which is 4 kilometers per hour. And then the river, for it is flowing at a velocity of, the river is flowing at a velocity of 3 kilometers per hour. Okay, find the time that it takes the boy to cross the river. So they want us to get this time. First of all, we need this distance SC. And also we need this velocity VR. So our time will be SC, distance SC over VR. We come and get our VR first from here, but our VR is going to be the square root of, we get 4 squared plus 3 squared, which is going to give us 5 kilometers per hour. Okay, then they're telling us that and then we need to get also SC. So to get how are we going to get SC? You see that this SC from here up to here, if I know this distance from here up to here, so I can get, because they how far down the stream, they want us to get this. But first, we can use, if you hold this angle here, theta, you can see that my theta is going to be equal to this over this, equal to this over this. So there, my tan theta is going to be, look at this, it's going to be opposite, which is 3 over 4, still equal to 2. Now these are velocities, but now I calculate it also using the distance. It's also going to be the distance BC over the distance AB. All from there, and use it as gravity. I think you can see that. So tan theta is equal to this over this, which is less equal to also BC over AB. So in simple terms, which will be, you see that now I have 3 over 4 equal to my BC, which I'm looking for, and I have AB from here up to here, it's 100. So from there, you can start my BC, it's going to be, and I cross multiply there, I'll be having 3 times 25, which is 75 meters. So I have now BC. But if I have BC, I can get I can come and I get my SC. So now my SC is going to be the square root of, now it's my S is going to be the square root of this, and then the square of this. It's going to be AB squared then plus BC squared, which is going to be The square root of AB is 100 squared 75 squared. So from there, my SC is going to be it's going to be 125 meters. So that's my SC. So I can get now my time. So my time is going to be, remember our SC is in meters, and this is in kilometers. I think you can see. It's going to be SC over VR. So our SC you can convert it to kilometers, which will be 0.125 kilometers. So now this is in kilometers and this is in kilometers. 0.125 over VR was that. So our time now is going to be 0.025 hours, which can be, if you convert them to seconds, 0.025 times 3600 in seconds. So from here, my time is going to be 90 seconds. Okay, after getting that, the distance up downstream, how far it goes downstream is the distance BC. So downstream is going to be according to BC, which will be 75 meters, as simple as that. Okay, when we come to this one, a man who can swim at, the man can swim at, so they are giving us of a boy or a man, 2 meters per second in still water, which is to swim across a river. They are giving us the distance of the river wide as quickly as possible. So whenever you hear the word as quickly as possible, it means that they need the shortest time possible. If they ask for the shortest time, it means that we use this as you're going to see. The river flows, so the velocity of the water of the river is 0.5 meters per second. Find the time taken to cross the river. So this is as quickly as possible. Still, start by sketching. So this is our river. They are telling us that the river is 1-2 meters wide. Okay, so we have now a point A, then we have a point B. Okay, so as quickly as possible. Now the boy is going to be traveling in as quickly as possible. It means that now if this boy comes from here up to here, we have crossed as quickly as possible. So here we have 2 meters per second. And then how far downstream? It means that this boy, this would be our resultant velocity in that order. Of course, we are going to be having the flow of the river 0.5 meters per second. So this is VR, and this is how far down the river that man will go. So remember around the time taken, shortest time is going to be, or it's get AB over VB, velocity of the boy, which will give us 120 divided by 2. So this will be 60 seconds. The shortest time always is when this boy moves from here up to here. That's going to be the shortest time. By the time, if they are asking just the time he uses, we've seen how we get this SC divided by the velocity using the resultant velocity. How far down the stream it travels. So this is Roman numeral 1. The Roman numeral 2, how far it travels, you get this angle here. So they are not asked to ask the angle. If they are asking for the course, you need to say this would be the course. But now let us use this to get how far this BC. So how do we get that? You see that this one is given our tan theta is equal to the opposite over adjacent, which should be the same as, in terms of now distances, BC over AB. So from there, I need this BC. So see that now BC will be equal to 0.5 over 2 times AB. So this will give us 0.25 times our AB, which is 120, and that is going to be 30. This is a quarter, 30 meters, as simple as that. So this boy will go 30 meters down the stream. So what's the difference between this and this? Here, they want the shortest time. If they ask for the shortest time possible, you always get, this is how we get the shortest time possible. But if they ask just for the time it takes the boat to cross the river, then what it means, you always use this distance, this one here, and then you use the velocity that is used to cross this distance. So whenever they ask find the time, just without putting the word shortest or as quickly as possible, you get the velocity, because this is going to be the distance this boy will cover. And then this will be the velocity is using, because this velocity is the velocity that when you can swim, and then the velocity of the river. So we get the resultant velocity divided with this length there. So that's it, members. I wish you well.